Let's look at a couple of examples. If we want to graph y equals 2 secant of 1/2 x, the first thing we're going to do is graph the reciprocal function of that. The reciprocal of secant is cosine, so we want to start by graphing y equals 2 cosine 1/2 x. When we do the reciprocal function, we're going to keep in any types of transformations that we had. All we're doing is changing this function to its reciprocal function. We're going to go through everything that we did in the last section when we were graphing sine and cosine. The first thing we want to look at is our period, because this is going to have a horizontal stretch. Our period is 2 pi over b. That would be 2 pi over 1/2. We end up multiplying by the 2. That gives us 4 pi for our period. So we can take our x values for our key points, which would be 0, pi over 2, pi, 3 pi over 2, and 2 pi. For each one, we're just going to take it and do the same thing that we did here to get our period, and that is multiply by 2. So we're going to take each one of these times 2. That gives us 0, pi, 2 pi, 3 pi, and 4 pi. That's where the locations of our 5 key points are going to be. The other thing that's happening here is that we've got a vertical stretch because of this 2. So that means the amplitude of our cosine graph will be 2. That means we'll have a maximum at positive 2 and a minimum at negative 2. Now I'm going to draw my cosine function in here. Remember, cosine starts at the maximum and goes down. So my function is going to start up here at the point 0.02. It's going to go down to the x-axis, then down to my minimum, which will be at 2 pi negative 2, back to the x-axis, and back to the maximum. Now, because of the way the secant function works, I'm going to continue this just a little bit to the left. So I'm going to put another point in here at negative pi, which is where this would come back down to the x-axis. There's my cosine function that I'm going to use for a guide. I'm going to draw in the vertical asymptotes here, and then I'm going to transfer everything to another graph. For my secant function, I've got vertical asymptotes any place that this graph is crossing the x-axis. So I've got 3 vertical asymptotes drawn in there. That means I'll be able to draw 2 of those U-shaped branches in there. After that, it's just a question of taking my graph and flipping it. So this part is going to flip up and make a branch going up like this. This part is going to flip down and make a branch going down. Now I'm going to go over here and draw this a little bit better. So I'm going to put in my vertical asymptotes as dotted lines. And then I have my minimum points and my maximum points. That's where it meets the graph of the cosine. So I have the bottom of my U is right here at the point 0.02. And for this one, the top of my U is at the point 2 pi negative 2. So now I've got 2 U-shaped graphs, and that actually covers an entire period, because from here to here is actually 4 pi, and that was the period when I drew my cosine function. So I really do have one period covered. Let's do another graph. This time it's for a cosecant function. So this time I'm going to be looking at the sine function, since that's my reciprocal function. I want to start by graphing this. For this function, I've got a phase shift, which is going to take my graph and move it to the right by pi over 2. And then I've got an amplitude change. My amplitude is 3/2. For my phase shift, I'm going to start with my 5 x values. To move this to the right pi over 2, I actually want to add pi over 2 to each of these. That's going to make this pi over 2. This is going to be pi. This is 3 pi over 2. This is 2 pi. And this is going to be 5 pi over 2. That's going to change my x values. This is just going to change my y values. it's going to multiply every y value by 3/2. So that means my maximum y value is going to be at 3/2. My minimum y value is at negative 3/2. Now I'm going to graph my sine function. I'm starting it here, so this is where my x-intercept is. Then here I'm going up to my maximum, back to the x-axis, down to my minimum point, and back to the x-axis. So there's my sine function. Now for my cosecant function, I'm going to draw it in a vertical asymptote anywhere that this has an x-intercept. That gives me a vertical asymptote at pi over 2, at 3 pi over 2, and at 5 pi over 2. And then I'm going to take my graph and flip it up for this part. I know my two functions meet at this point. So my cosecant function is going to go up like this. And then between these two asymptotes, my two functions meet at this point. My cosecant function is going to go down on either side. I'm going to redraw just my cosecant function over here. One thing that you should do when you're sketching either cosecant or secant, make it very clear where your asymptotes are or label them. If you're going to label them, write it as an equation. For example, this one would be x equals pi over 2. That's one asymptote. Here's another one at x equals 3 pi over 2. And then we also have one at x equals 5 pi over 2. Also, you need to put in the maximum and minimum points and label those. So I had a minimum point at pi 3/2, and my graph goes up on either side from that towards my vertical asymptotes. In between these two asymptotes, I have my maximum point at 2 pi negative 3/2, and my graph goes down on either side from there towards my vertical asymptote. That way I've just got the graph of my cosecant and I've got all the important things labeled, which are just these points that are the minimums of or the maximums of the branches and my vertical asymptotes. One more thing we can do that might help you understand this a little bit better is to look at a graph and try and identify what the equation would be. If we look at this graph, it would really help if we just sketched in our reciprocal function. Wherever there's a vertical asymptote here, I'm going to put an x-intercept, and then I'm going to have these meet at these minimum and maximum points. So there's an x-intercept there. It's going to meet the graph there, and here's an x-intercept here. Now I can look at this function and figure out what it is. So I've got a couple of different things to look at. One is the amplitude. For this graph, it's going actually from -1 to 1. That means the amplitude didn't change. So for my reciprocal function, my amplitude is 1. The other thing I can look at is the period. So to complete one full cycle, it went from 0 to 4 pi. If I want to find the b, I can take this and solve for b. This is going to give me b equals 1/2. The other thing I need to know is which function this is. Is it sine or cosine? Since it's starting here at the origin and going up, that means it's the sine function. So this graph that I drew in here would be y equals sine of 1/2 x. That means that the original graph, so this graph, is the graph of y equals cosecant of 1/2 x. Let's do the same thing for this one. This one is a little bit harder because if you just start out like I did by putting in your x-intercepts wherever there's a vertical asymptote, and when you get to here and try to draw this, you notice that this isn't centered across the x-axis. What I want to do now is look for where the middle of this is. So if I'm going halfway between these two branches, that's right at 1. My reciprocal function is actually going to start at 1 and go up to here. It's going to come down and meet this function here, and then go back up to that line. So if my graph is offset a little bit by a vertical shift, then I have to redraw where the middle of that would be. Looking at the reciprocal function that I have drawn in there, the minimum is at 0, the maximum is at 2. For my amplitude, that means the distance between those two is 2. If I divide that by 2, that still gives me an amplitude of 1. There's no vertical stretch or shrink. Then I also want to look at the period. I want to go from the beginning of this cycle to the end of this cycle. That's from negative pi over 2 to 3 pi over 2. I want to see what that total distance is. If I figure out that total distance, that's actually 2 pi. That's the original period for my sine and cosine functions. That tells me that there's no horizontal stretch or shrink either. The next thing I can look at is the vertical shift. If we look at this graph, it looks like the graph of cosine because it's starting at a maximum and going down. Our normal cosine graph would have started at 1, so that means this one is actually shifted up by 1. This would look like a cosine graph shifted up 1 unit. There weren't any other changes to my cosine graph. That equation would just be cosine of x plus 1. To write my reciprocal function graph, this equation would be the reciprocal of cosine, which is secant. I would just have secant of x plus 1.